Namaste dear students. So last class we studied about normalization rules and we studied about ER diagram also. Some sort of rear diagram also we studied. So so what do you mean by normalization rule? Normalization is the process of organizing data in a database. This includes creating tables and establishing relationships between those tables according to rules designed both to protect the data and to make the database more flexible by eliminating redundancy and inconsistent dependency. So we studied about normalization rule also. There are four types of normalization rule. First normal form, second normal form, third normal form and BCNF. Actually BCNF means extension of third normal form also, or we can say higher version of third normal form. So we studied all those things in last class. And normalization means that is process of organizing data in a database. So otherwise what happens is it's not possible to get the more simple data, or it's not possible to set the data in simple way in the database. So that is very important. And last class also we studied about ER diagram. So what do you mean by ER diagram? ER diagram is a visual representation of data that describes how data is related to each other. How data is related to each other. So ER diagram normally it shows some diagram like rectangle, ellipse or oval shape or diamond shape and some lines. Sometimes it is represented by using the arrow mark also, but arrow mark is not there in your syllabus. So we have to study about ER diagram. So ER diagram means ER diagram is a visual representation of data that describes how data is related to each other. An ER diagram shows the relationship among entity sets. An entity set is a group of similar entities, and these entities can have attributes. In terms of DBMS, an entity is a table or attribute of a table in database. So by showing relationship among tables and their attributes, ER diagram shows the complete logical structure of a database. Just go through this one. So what do you mean by ER diagram? And here a simple ER diagram is given for you can take it as an example. And here in ER diagram, see in this diagram, student and college, two rectangles, student and college, that indicates the entity, and student, it is connected to three ellipses, or we can say oval shape diagram. Student ID, student name and student address. Here student is an entity and student ID, student name and student address attributes of that particular entity student, and it is connected to the relationship that is study in, that is relationship, and another entity is college. So student is connected with college by using the rectangle, by using the rhombus, or we can say diamond shape, and diamond shape that represents the what is the relationship between student and the college. Here college, it is connected to two other attributes, college ID and college name. So what happens is student is an entity that can be connected to the college using the relationship, and relationship between these two items or entities, that is by using the rhombus or diamond shape. So this particular diagram that indicates ER diagram, and it shows so what is the relationship between the entities and each entity, so what are the attributes of such entities and all those things explained in a simple ER diagram. In a simple ER diagram, that's why we need ER diagram to represent the relationship between the entities and what are the attributes of entities, and all those things should be described by using the simple ER diagram. So that's why we need ER diagram. Just move on to the next diagram or next slide, and here there are some geometric shapes and their meanings in an ER diagram. Here first one is rectangle that represents entity sets, ellipse that indicates the attributes of particular entity, many attributes. In the previous slide, attributes of student is student ID, student name and student address. And next one is diamonds that indicates the relationship set. So how an entity related to the another entity, right? Next one is line. So lines that indicates the link between two entities or link from one entity to the relationship, or one entity sets to the another entity sets through the relationship set, etc. Next, double ellipse that indicates the multi-valued attribute. It is not there in your syllabus. Dashed ellipses, derived attributes, and here these two things are not in your syllabus, but it is there in database concepts. So in ER diagram it is there. Next, double rectangles. Actually, double rectangles that indicates the weak entity sets. Weak entity sets, that means one entity it is dependent or depend on another entity. In such cases it is called as weak entity, that we will discuss in later slides. And next, double lines. Double lines specifies the total participation of an entity in a relationship set. Double line indicates the total participation. Next, move on to the next slide, that is components of ER diagram. An ER diagram has three main components: entity, attribute, relationship. Third one is relationship. See, this diagram indicates the ER model, entity relationship model, and it includes three components: entity, attribute and relationship. See, first you can take this one, entity. Actually, an entity consists two types. One is weak entity and other one is strong entity. Strong entity, it is not there, or it's also sometimes it is called as composite entity. It is not there in your syllabus. Entity, only that much is enough. Only entity you have to study. An entity is an object, it's a place, or it may be a person, an entity having some attributes. Next component is attribute. So what do you mean by an attribute? An attribute that specifies the property of an entity. Actually here attribute, there are four: key attribute, composite attribute, multi-valued attribute and derived attribute. See, according to your syllabus, only two attributes are there: key attribute and composite attributes are there, and last two attributes like multi-valued and derived attributes are not there. Okay, let it be there. But under DBMS and under ER diagram, four types of attributes are there: key, composite, multi-valued and derived. Okay, so third one is relationship. It's one of the components. Here relationship, one to one, one to many to one and many to many. According to their approach, according to the approach of one entity to another, or one entity to the relationship set, there are four types of relationship: one to many to one and many to many. But it is not there in your syllabus. It is actually relationship in your syllabus is binary relationship, tertiary relationship, and third one is recursive relationship is there. So three types of relationship, but according to their approach there are four types: one to many to one, many to many relationship. Okay, next move on to the next slide. So that is entity. So what is an entity? An entity is an object or component of data. It's an object or component of data. It is called as an entity. And one more thing is, an entity is represented as rectangle in an ER diagram. That can be represented by using rectangles. And you can take this example, below example. It is, in the following ER diagram we have two entities, student and college, and these two entities have many to one relationship. as many students studying in a single college. See this, two entities, student and college. See, an entity can be represented by using rectangle. So two entities, student and college, and here many to one relationship. That means many students can approach or having the relationship with the college. So that indicates many to one relationship. Next, move on to the next slide. So weak entity. So what do you mean by weak entity? An entity that cannot be uniquely identified by its own attributes. An entity is there, it cannot be uniquely identified by its own attributes. That means which is dependent on the another entity. That is dependent on the another entity relationship, and it is called as weak entity. So example to this one is weak entity can be represented. See this diagram here, bank account is a weak entity because bank account, it is fully dependent on the bank or depend on the bank. So a bank may include the IFSC code and branch number and some other code is there, IFSC or some other code, and based on this we can have the bank account. If bank account, if it is belongs to the SB or savings or current account, so all those things depend on the bank. So that's why bank account is weak entity. So that's why it is represented by using the double rectangle. Double rectangle. So it is called as weak entity. Next one is attributes. See, an attribute that describes the properties of an entity. Properties of an entity. An entity is represented by using the ellipse, or we can say oval, in an ear diagram. There are four types of attributes: key attributes, composite attributes, multi-valued attributes, and fourth one is derived attributes. But according to your syllabus, key attribute and composite attributes are there. Multi-valued and derived attributes are not there in your syllabus. So what do you mean by key attribute? Key attribute represents the main characteristics of an entity. It is used to represent the primary key ellipse with underlying the line represent key attribute. See this key attribute. A key attribute can uniquely identify an entity from an entity set. See, normally key attribute can be recognized or identified by using the underline. So key attribute must be underlined. That must be underlined. And here you can take an example. For example, we have student information database or table or any other ER diagram, regarding to the student. And the student roll number can uniquely identify a student from the set of students. That means key attribute is represented by oval shape, and it should be underlined. Key attribute should be underlined. See, for example, student is an entity, and can have the roll number, student name, student class, student section. And here we can represent each and every student by using his roll number. So roll number, that must be key attribute, because no two students can have the same roll number. So each and every student should have the different roll numbers. So that's why student is an entity, roll number is its key attribute. So that should be underlined here. Underline is specified, and other entities are name, age, address. Name, age, address. Okay, these are about key attribute. It's very important. Key attribute in your examination purpose also you can expect this question for 1 mark. And weak entity is also one of the important question. So what do you mean by weak entity? How we can represent? So weak entity can be represented by using the double rectangle. And here under attributes, Key attribute means that is used for the unique identification. Unique identification, we need key attribute. It's just like a primary key, right? Next, composite attribute. So what do you mean by composite attribute? An attribute that is combination of other attributes is known as composite attribute. For example, in student entity, the student address is a composite attribute, as an address is composed of other attributes such as pin code, state, country. Pin code, state, country. See, you can take student information database. So under that one, student information database, a student is an entity and having student roll number, student name, student age, and then student gender and student address. So many things are there. So I mean, these things, these attributes, here address can have some other attributes like pin code, state, and country. So address is an attribute, itself is an attribute, and having some other attributes. Address is the attribute of student, address is the attribute of student, and address having some other attributes like pin, state, country. So that's why address is a composite attribute. Address is a composite attribute, and this one also very important. So what do you mean by composite attribute? So you can expect this question for 3 marks or 2 marks. For 3 marks you have to draw this diagram also. For 2 marks just you need to explain, explanation is very important, right? Okay, we'll go to the next component, that is relationship. A relationship is represented by diamond shape in ER diagram. Diamond shape, or we can say rhombus. It shows the relationship among entities. Teacher teaches student. Teacher teaches a student. Here teacher and student. Two entities, and here relationship is teachers. It uses rhombus or diamond shape. A relationship describes relations between entities. Relationship is represented using diamonds. There are 3 types of relationship between entities: binary relationship, tertiary relationship, and recursive relationship. See, in these 3 relationship, binary and recursive relationship is very important for examination purpose also. Tertiary relationship and its explanation is not properly in your syllabus. So no need to worry about that one. Just go to the next slide. So binary relationship. See, binary relationship means relation between 2 entities. They are divided into 3. They are divided into 3. See, first one is one-to-one relationship. One entity related to another entity. See, in the above example, one student enroll one course, and a course will have only one student. Course will have only one student. See, this diagram indicates one-to-one relationship. Student and course, 2 entities, and here diamond shape that indicates the relationship between student and course having that will have only one student. A student, that means only one student enroll to that course. So that is one-to-one relationship. And here one-to-many relationship, this diagram, third diagram, represents the one-to-many relationship, an entity that related to the many entities. A student can opt more than one course, that is one-to-many relationship. And related to this particular diagram, we'll have the explanation in next slide. See, one-to-many. One entity is associated with many number of same entity. And here diagram is like this. Student enroll a course. One student can enroll many courses, or we can say a course will have more than one student. Sorry, not like that. Here many courses are there. A is a student that is connected to many other courses. That is one-to-many relationship. And next one is many-to-many. Many students can enroll for more than one course. Many to many. Here one n is missing here. Here many students can enroll many courses. Here another n is missing. So no need of that one. Okay. So these are about many to many relationship. Many students can enroll for more than one course. See this diagram. Here B indicates the student. Actually B that is connected to two courses, A that represents the course, and second B also that is connected to more than one course, and third student that is okay that particular student connect to only one course. Okay, these are about many to many relationship. And next one is participation constraints. So what do you mean by participation constraints? See, constraint means some restrictions. Here there are two types of participation constraints. See here one is total participation and second one is partial participation. So what do you mean by total participation? Each entity in the entity is involved in the relationship. Each entity in the entity is involved in the relationship. It is called as total participation. Is represented by double lines. Double lines. Second one is partial participation. Partial participation means not all entities are involved in the relationship. Partial participation is represented by single line. See, partial participation represented by single line, total participation represented by double lines. So these two things very important for your examination also. See, first one is total participation. That means each entity in the entity is involved in the relationship. That is total participation and it is represented by double lines. Partial participation means not all entities are involved in the relationship. Some entities are involved in the relationship. This is called as partial participation and it is represented by single line. So you can expect this question for 2 marks. So what do you mean by total participation? Or what do you mean by partial participation? It's very important for your examination purpose. Next, see this diagram. Here, first entity that is connected to the relationship set by using the total participation. That means all entities connected to the relationship. That is total participation and it is represented by double lines. Double lines. Next, that relationship that is pointed to that particular entity. That means single line it is showing single line. So that indicates partial participation. Partial participation. See, this diagram is very important for your examination purpose. Just go through this. Next, move on to the next slide. Cardinality. See, cardinality specifies how many instances of an entity related to one instance of another entity. That specifies how many instances of an entity is related to one instance of another entity. One instance of another entity. Here instance that specifies row, we can say row or tuple also. Tuple also sometimes it is to represent tuple, sometimes we need the term instance. So cardinality specifies how many instances of an entity relate to one instance of another entity. Or another definition is here, cardinality is total number of tuples or rows of relation or table. Total number of rows or tuples of relation or table. Okay, next term we need to explain is that is ordinality. And ordinality that is closely linked to the cardinality, while cardinality specifies the occurrence of a relationship, ordinality describes the relationship as either mandatory or optional. See, most of the times ordinality it is closely linked to the cardinality and it explains cardinality specifies the maximum number of relationship, whereas ordinality specifies the absolute minimum number of relationships. When the minimum number is called optional, and when the minimum number is usually called mandatory. And one more term is missing here, that is degree. Degree means it is the total number of attributes of relation, total number of attributes or column headers of relation or table. So cardinality means total number of tuples, that means rows. Degree means total number of columns. So it's also very important, cardinality and ordinality. You can expect this question for the examination. And recursive relationship. So what do you mean by recursive relationship? When an entity is related with itself, it is known as recursive relationship. That means recursive relationship means an entity, it is connected to the, or it is related to the same entity. It may be directly, or sometimes we can say indirectly by using the some other relationship or rhombus, and such relationship is called as recursive relationship. So last year you studied about recursive functions. In first year syllabus, recursive function is there. Recursive function means a function is connected to the same function again and again, directly or indirectly. It is called as recursive function. See, recursive means it's a term, so that indicates that is related to itself. That means when an entity related with itself, it is known as recursive relationship. Recursive relationship. So it's recursive relationship also very important. Next term is generalization and specialization. Before the explanation of generalization and specialization, just go through this one, some approaches in programming languages. So last year you studied under object oriented programming language, you studied about, so what are the importance of object oriented programming language whenever we have the procedural oriented programming language. See, in C programming language, that uses top down approach. See, in top down approach means in which given program or given problem is divided into number of pieces, and then we are going to solve such pieces. That means again and again we have to divide the number of program into some pieces. That means each piece that must be individually executable one, that means individually solvable one, then only we are going to stop the process of dividing. So it is top down approach. And C++ programming language, which follows bottom up approach. See, bottom up approach means first we are getting solutions to the some smaller programs, and we are going to combine the solutions to form a higher level program. It is called as bottom up approach, and bottom up approach, it is completely opposite to the top down approach. See, this generalization is a bottom up approach. See, generalization and specialization is very important aspects in DBMS concept. Generalization is a bottom up approach in which two lower level entities combine to form a higher level entity. In generalization, the higher level entity can also combine with other lower level entity to make further higher level entity. So these are about generalization, and it is opposite to the top down approach. So what do you mean by specialization? Actually, specialization is opposite to generalization. Whereas in generalization, you are going to collect the small pieces to form a higher end or higher level entity. But here we have an entity, higher level entity, and that entity can be broken down into two lower level entities. In specialization, some higher level entities may not have a lower level entity sets at all. So these two things are very important. Generalization, which follows bottom up approach, specialization, which follows top down approach. And end product of generalization is higher level entity, and end product of specialization is lower level entity. That means you are going to divide the higher level entity into lower level entity. So example to these two things are given below in this diagram. So generalization, example to generalization is, so that is account. Here account is an example to the generalization. So account that will formed by using the current and saving accounts. So we need to specify which one is this, current account or saving account. And under specialization, example to specialization, student is a set or group of elements and which can be divided into two. See, in the previous one, generalization, we are going to join the account, current and saving account, which will form an account. But under specialization, student, example to specialization is student, and further divided into ex student and current student. Ex student and current student. Okay, these are about generalization and specialization. So it's very important for your examination purpose. See today's concept. So starting from the year diagram and its attributes and components of ER diagram, entity, and then attributes and relationship, and all those things are important. And starting from entity to the generalization and specialization, very important concept. And you can expect generalization and specialization questions in final examination also. You can expect these questions for 2 marks or 3 marks. For 2 marks, just you need to explain generalization and specialization. For 3 marks, we need a diagram to explain. Okay, students, and worksheets I'm going to send along with this video link, and study properly and answer to the worksheets properly, and we'll see you next session.